Okay. So we will be continuing with the spaCy now, and I've already shared the notebook with you, and stemming and all we'll be seeing again. But now we will be using a different module that is called spaCy. Okay, it is an open access module library of Python. Python is open access. That means you can see the source and you can manipulate the source also. If you want, to change something, or you want to add something, or you want to change any module, or you want to see the code, you can always go and see. It is an open access, so you can go there and see. So we already have seen what is tokenization, part of speech and all, lemmatization and all, stemming we have seen. And I have put the difference between stemming and lemmatization. So lemmatization gives you the accurate word actually, and but stemming will may not. Okay, because lemmatization actually works in a part of speech also. So if it is ing, it may return ing only. If it is counting, it may give counting only. But if I stem it, so it may give me county, CONTI only. Just like we have seen in flying, it gave FLI instead of fly, FLY. Stemming may give me FLI, but lemmatization will give me FLY. Okay, so it will be giving me the exact word because it has its own corpus. Okay, so it has its own corpus. It looks into that, and that is corpus. Meaning, we say corpus. Basically, it has dictionaries. So if you have a dictionary, it checks from the dictionary. You can create all your own dictionaries and get it from there also. So it checks from the dictionary, and that is the reason why it may be little slow. So if you look at the huge data sets, bigger data sets, then lemmatization would be slow, but it will be accurate. Word will be there. It is not that instead of the actual word, it will give something else. Like FLI, no word. FLY, word is FLY. So counting also CONTI won't be any word, but counting is and count is. So lemmatization works on the part of speech also. So that is why it may be giving you counting only, but eating and all it will not. It will come to the base word. Most of the time it will come to the base word. Okay, and actually ing English is a very funny language. So like ing, it can be a adjectives, it can be adverb, it can be a verb, or a single word can be anything. One word can be any. So ing may be a gerund also, or it may be a present participle also. So one is verbal noun and one is verbal adjective. So it can be anything. So English, it is possible that your base word may not be exactly what you want. Like counting, if I want count, then it may give me just counting only. That it is okay, fine, because it may be considering it as a gerund, and if it is a gerund, then it's okay. The word is okay. Verbal adjective or verbal noun depends on that. So it checks the part of speech also. So it may be not exactly what you want, but stemming would give you the uh, base word. But again, in some cases, it may not work properly, right? So instead of was, it will give me DE, lemmatization, which is actually the base, or what we call is a helping verb. DE is a helping verb. Anyway, so we have a tokenization, part of speech, tagging, then dependency parsing, and tokenizations and all. In stemming also there are different ways of doing that. Dependency parsing is it assigns syntactic dependency labels. It gives labels actually. Uh, syntax Syntax is how it is arranged. Relation between the tokens and the individual, like subject and the object. Like we have subject and object. if I give you an English sentence, I am going to the market, or I am going to market. So I is subject and object is market. We know that from our school days. Okay, so it gives me dependency parsing is possible, so it is more accurate. Lemmatization is there. Sentence boundary detection is there. It segments individual sentences. It can find and segment sentences. And then we have a named entity recognition. This is very, very important sometimes in real world objects. Person, it is a person or a company or what. Okay, name entity relationship is important to find out whether you're talking about a person, a company, or a verb or something else, or location, LOC, location also. Then we have entity linking, this ambiguity, like textual entities to unique identifiers in a knowledge base, identifies that, uniquely identifies that. Similarity is there, then text classification, rule-based matching, and training is there. So we'll be seeing them, and what is important, we'll be seeing that. But for that, spaCy is not there, so I'll have to install it. So for installing, I have pip install spaCy. The first thing is I have to install spaCy, and then only I can go ahead. Once it is installed, then I can go ahead and install other modules also. I'll be installing that's okay. I'll be installing with Ian English. Otherwise, it doesn't work. It does. Okay, it doesn't work. I have to install this one. Python in spaCy download Ian. Let me run this. Now it says that the requirement is already satisfied. It will, but still it downloads few things like en core web, and that is required. Otherwise, it is not installed, and without that, I won't be able to work. So this is required. This command is required to install spaCy. spaCy is inbuilt, but few modules won't get installed unless I use the other command. Requirement is there, so we don't have to worry about that. No. We have to load the English words. Few tell you few things. Okay. So we use load to load the English module, as I told you. Then we have in core web SM, that is having 111 MB of data. It is multi task trained, and then we have MD, like Encore Web MD, that has 91 MB of data, and Glove vectors, it use Glove to vectorize the data, and the Glove actually is commonly used these days for vectorization. This is a module and training module, and it is normally used, and it's a huge data corpus. So for vectorization, you can use Glove also, and spaCy can use Glove also. And then we have in core web LG, that is again my English multitask, CN trained onto nodes, and it has a big data, that is 789 MB. Okay, so again it use Glove. We'll see that what all it installs, and first we have to import spaCy. I have the sentence, so just copy paste. We try to be slow. One by one I'll do, so that you can understand better. First is the text, and I have to load. So np is equal to load, and we have now English core web SM. That is the first one. Yep, spaCy.load. So I'm not giving spaCy. No, this, yeah, red line will go. It gives you errors if you there's something wrong in the syntax. All right. Now, token NLP on text, and let's print it. Let's print and see what we get. We are not tokenizing anything. We're just loading and putting NLP, applying NLP on that. Nothing will happen as such. It's only that it will be converted into text format, normal, right? Now we can perform the things we want. Now we want the names. So pipe names I want. With those, 1 minute. Okay, I have to put some few things here. Pipeline function it uses to process that. So we have the things like we have to check. Actually, let me check first what all pipes we have. I'll tell you about the pipes. Tagger, parser, and null. Name, entity, relationship. These are the three things which are there. Now, Python actually uh, can work on pipes. Like what it can do is it can pipeline the commands. Like suppose we have three here. We have tagger, parser, and null. These are the commands I want to execute on my text or anything else I want to. So what I can do is I can put it in a pipe and I can uh, pass on my data through it, and all the three commands one by one will be executed. So that is what pipe is doing. Pipe actually pipelines your commands, the commands you want to give. Now these are the inbuilt with NLP, that is with the text it has, and I can have the doc also. I can see what is there in the doc, spaCy tokens, the doc. So it won't give me, actually it will just display doc only. We'll be using it and we'll see. Okay, so as of now it won't return anything, but it will when we will be using that. So let's have tokens in token. TK, we have the tokens. Yeah, we have the tokens and we'll just print it. It is all tokenized now. You'll see it won't be visible here. It won't be visible here, but now let me put the loop for tokens in variable is tk, and I'll print tokens. Word can be anything. It is just a variable, and token. I have used token, so I'll put token. You can see that. So it was broken up, but it was not visible here, but it is already broken. So tokenization has already happened. Now what all we can perform, we can put through the pipeline also, or we can just simply use and English on this and to see how we can tokenize again. So let me do it, put everything together, and now I'll use English. Now, sorry, from spaCy lang.en import English. I've imported English, and this is another way of doing it. Then load English tokenizer, tagger, parser, null, and word vectors. This is how I load that. NLP is equal to English, round bracket, and text. Oh, we already had this. Then object is used to create document. NLP on text. My doc will be created. That is different linguistic functions will be performed. Then we have created a list which will be storing the tokens from the doc which we created, and we will be printing the token list. It is similar to what we did earlier. Okay, it is similar to what we did earlier. We have printed everything here, not separately. So it is similar, but now we are using English instead of E and web. So we have different options to do things. Now let's see the stop words. We'll see how many stop words we have. From spaCy.lang, this one. En, that is English. Stop words, import stop words. This is a list I have created, empty list to store my filtered sentences. Now applying a doc NLP on the text which we already had, like this one. NLP in English is there. So NLP we have applied. Now for words in doc, we are reading the words from the doc, and if words dot is stop is equal to false. Okay. If it is not a stop word, then we just append it at the word and we'll print it. So there will be no stop words now, and you can see that there are many. Will display learning, data science, discouraged, challenges, and all. Rest have gone. So you can see that it is clearing every stop word there, and again you can always add up the stop words you want, because this is just a list and you can always add to create that. Now lemmatization will be doing. So again the spaCy we have already imported, I don't have to. The language I need, sorry, I wanted to press enter now. spaCy we have done that earlier, so I'll use again NLP. Use NLP so that we know that what we are trying to do. Okay, lem is equal to NLP. We don't have a text, so text here. Equal to 1 to remove. What happened? And text line text with some Unicode new. Okay. Right. Let me first run it and check if it's working or not. Okay, it is working. Now I can do what I can do is find okay, find the lemma for each. Because we have to lematize. We are performing lemmatization for each word. So for word in lem, lem is there. We have to print word dot text. We have found the word. Okay. And the word dot lemma. Lemma is here, so it's okay. So this one, we're reading each token and just finding the text and the lemma. So we'll run it and see the base. Work converts to be, walking to walk, converts in will be in preposition. The garden is garden when the earthquake is again hit the town. Most of that is same, but you can see ing there, it has changed. So even work, so you can see that you can use, and had, have, gone, go, to had, ka, have is the base word of had. The will be station, then is again be, standing is stand, and so on. You can see that it's simpler, better. So lemmatization, we have the text. What we have to do is NLP, just apply NLP on that, and you can see that it performs a lot of things. So three things it performed. You can see that. 1 minute. Let me show you. Tagger, parser, and NER. And if you're using English, then it uses more. So in pipeline, the modules, the functions are there, and it will perform on its own. Okay. You can have with a simple, more appropriate example to see. So we have a computer. I put it like this. Okay. Lem is equal to. I just, if I have created, then don't have to do anything else now. I'll just put this. I'll put U before that Unicode for Unicode. Now I can print it for Word in lem print word.text. Get the text and word.lem. Just run it. See, computer is computer only. Computer. There are two computers. Oh, sorry. Computers. Let me make it computers. Now let me run it. Okay, so computers and computer gives computer only. Computed, computing again, and computes again as compute only. So it gives you the base words. And as I told you, ing could be gerund, so it may get confused. Quite possible. So now let me find the text, analyze noun phrase. Just want to find out the noun phrases. So I'll I'll be using a compounded for loop now, and I'll show you how it is used. So we have the text already. So in doc we already have. Doc we don't have the doc. So I'll have the text again. I'll put another text and then analyze it. Use directly print command, and I'll use a compounded for loop, and this is something new which has come up now. Now what happens here? This is to understand, the rest is okay. What we are doing, we have to read it from here for chunk in doc.noun chunks. Okay. This and output goes on the left side, and we put it in a square bracket. This is called a compounded for loop. Okay, so we have a loop where we can actually perform things in one line only, and very commonly used in Python. So if you look at some codes, you'll find this syntax very commonly used by the programmers. Okay, so whatever the output comes from the noun chunk, it gets stored in chunk dot text. We're just putting the text in the chunk. The variable is not is there, so chunk is already there for chunk. So chunk dot text will have noun chunks. Noun, that means from the text it will get you the noun and store it in chunk dot text. So in text actually in chunk. It will store in chunk. So we'll have it, and let me run it for you, and you'll see that only nouns will come out. They, the garden, the earthquake, the town, I, the station, she, the queen. It only noun came out. So noun phrases came out. You can see that. Okay, so this compounded for is very interesting, commonly used these days. Okay, so we'll have a bigger text now and find what we can do with that. Let's put the text. Would not like to type it. It's a big one. So when suggestion started working on self-driving cars at Google in 2004. The few people outside of the company took him seriously. Yes, if we talk about something which nobody has seen today, but someone has visualized it, others will just mock you and say that this is what nonsense you're talking about. But actually, everything is possible until you try. Nothing happens. So you have to try to make things happen. Everything will fall into places if you have the ideas and the vision and the desire to do the thing. You have to do things to make them happen. And just sit on the shore and wait for the fish to come to you. You have to jump into the water. Okay, so now we have a text, a bigger text, and with the different lines you can see. I have not put a comma there. It should not. It should be giving me an error. It should not. Anyway, it's okay. Now doc we are creating again NLP text. What I want to find out and what I want to retain depends on me. Okay, so I just want to retain the verbs. So I'll just copy this. And this time I'll change it to noun. I just want the verbs. Okay, I want verbs, and in this case, I have to change token. Tokens.lemma, lemmatization, the correct store. Earlier was text. I've used token instead of chunk. I can use chunk also. I can use chunk here also. Same thing, no issues. Or token in doc. Now I have put a condition here. Now, if token dot pos, that is part of a speech, is equal to verb, then it will be stored. Only verbs will be stored. Everything is happening on its own. Once I apply NLP, then your verbs, your nouns, everything is done. Lemmatization, everything is done. But how you want to, you can extract it from the text, from the output rather, doc. Right? If I print doc, you won't get anything actually. Doc we have. Let me print doc for you, and you see what you'll get. Just printing doc here. I'm not using here. See, you just get the text. You don't see anything unless you extract it. So let's run it and see if you get the verbs. So you get all the verbs in the text. Start, work, drive, take, can, tell, word, would, shake, turn, talk, say. So it has taken out the verbs from the text. And how we have done it? We have put a loop token.lemma for tokens in doc. If token.pause, that is part of speech, is equal to verb. You can change it. Whatever you want to find, you can find that. Part of speech we have already shared. I have already shared, so everything there can be extracted. So if I want to find the entities, I'll change the any name entity relationship or entity you want to find. You can find that also. Find the name entities, NER, phrases and concepts. So for entity in doc.ends, that is entities. Now print entity.text, entity.label. Okay, so entity is here, so it can be actually text or any other variable. See, for text is Sebastian, NORP. Then Google is organization. 2007 is a date. American is again NORP, that means me region. And record is organization. Earlier this week is a date. You can see that. So whatever I wanted to find, it has already found for me. I don't have to work, and that is why Python is very handy. You don't have to do things most of the things are done for you. Okay, now, so this I have not used compounded. It may create some confusions, so I have not done it. Now, part of speech I want to find. Part of speech, I can find that also. I have already the text. Uh, a word in text, print word dot text, word dot part of speech. Not applied on any other text. We already have the text, but something is missing. Str is not there. Str object has no attribute text. Yeah, it is not text. Word dot text. Where is that? I'll have to put this thing. Okay, doc. I'll have to get it from the doc. It is doc actually. It is doc. Let me see doc. I can use doc directly. Yes, you can see that part of speech, and this time it gives you a better output. You can see that it is adverb, proper noun, then proper noun, verb, adjective, then noun, punctuation, then verb. You can see that. It doesn't give you code. It gives you theme words. Sorry, the first few, four or three words of your determiners, like we have the word. It is or the part of speech. Verb is complete. Adjective adj. So you can find out actually. Det is a determiner. An the or determiners, and and other word is verb is your verb. So nouns we have, proper nouns we have. So we have these things. Easily you can find out. Okay. Then we have entity detection. That is finding the or recognizing the entity, identifies important elements like places, people, any that is what I was talking about, name entity relationship. We did it earlier also, but we'll just put some more text now. And we have we'll be importing now load. We'll be using Encore Web SM load. So I'll just have to import everything, then we'll print it. And compounded for has been used. So we have imported English, then Encore Web SM, and display, spaCy import display. Then we have created the we have called Encore Web SM load. We have loaded the pipe. NLP is equal to Encore load. We are loading that. Then New York Times. Then this is a news there. New York Times. We have used U for Unicode. Entities. Read it from here. Read it from here first, then on the left hand side. But tokens in New York Times dot entities. ENTS is for entities. That is from here. And NLP is applied. So we have the pipe there. We have the part of speech, entities, and everything is there. Tagging and everything is there. Lemmatization, everything is there. So what we are interested in is the entities. So New York Times, NY Times dot entities. Now where we are storing? We are storing on the left hand side. Token, we are storing token, then token labels and token label. See the difference, and we will print it. And I can now print it is. Let's run it. You can see that New York Times is GPA, that is place, organization, Tuesday is a date, and you get the label also. That is the number which we get. This is vectorization basically. So vector also we are getting it for my applying machine learning. I would be needing the vectors, so it is giving me the vectors also. So if I give a label, just label without an underscore, it gives me the token, and if we give with an underscore, it gives me the word itself. Okay, so it gives me the vector token, otherwise it gives me simple token, you can say that. So if I don't use a semicolon, then what we get is the number or the vector associated with the word, otherwise I get the word. That is, in this case, name entity relationship. Okay. So we are now doing dependency parsing. We have parsing, different type of parsings. That was there in the notes above. So we have to find that. I'll import everything again. That is not required. It is not required, but text is already there. We'll just put this thing. Let's put the loop and see if something is missing. Okay, from New York Times noun.chunks, we are reading the nouns chunk, then print chunk dot text chunk dot root text root dependency, then head text, and then display C dot render New York Times style entity and Jupyter. Jupyter 2, that is on Colab we are printing basically, so it is just showing you that. New York City, city, and subject and declared. Then Tuesday, you get the root text also. You get the chunk text, the root text, and dependency and the head text. So you get that. Tuesday is the date anyway. New York City, city, that is the root text we get. And then you can see one by one. It's a big text, so you can see like this. This is how we are going to highlight that. This is how we are highlighting it from the text. We say that entity Jupyter's true. So once I do that, for New York City GPE, it has, that is a place it has marked, and Tuesday date. So in a document, if I want to uh, highlight things, I can highlight using this command. So it will be number is a cardinal, 4 again is a cardinal, build bias bison Bizio, Bizio, Lazio, what is that? Blazio, Bill de Blazio is a person. Tuesday is a date. Orthodox is NORP. So we money is also there. GP is a place. Lindbergh, Brooklyn. So you get that September date. So it will highlight for you this one. This will do that. Otherwise, you can always. So you just find out chunk in New York Times noun chunks. It's noun is working on, and you can highlight the things. Okay, we have another way of displaying the things. We have spaCy also. Display spaCy is there. So I just wanted to. I'll see if I can get the graph. So text is how the text is linked. We load NLP, then text and display render doc style depth and Jupyter again to set true so that I can get the graph. And you can see that this is what I can tell. How the text is linked with each other. When started, Celestian and through again started. You can see that the link, how it is linked. In what 207. So this you can see how the things are linked. It is a big one. You can see that the graph is big, but this is how a relationship can be found. You can find the relationship between the name entity relationship. You can find using the above command. Either you can highlight or you can plot. Style you can give, different styles are there. You can get the style will have to check what all styles are there. That is there. So we can classify the text using spaCy only. So you have to import a few things. So I'll just put that and the data I have. I'll have to import the data, and I think I have the data for Alexa. So import pandas as PD, sklearn we have to call skbase and skpipeline. So transformer, mix min, count vectorizer and tfid vectorizer to vectorize the data. We have called that, and I need the data. And let's see if I have Amazon Alexa .tsv file. Let me check. Yeah, I have that. This file is there, but it is again in text form. Let me open it. I'll have to convert that. Let us upload it first. Yes, it is again a text file, so I'll convert that and just rename the file. The copy is made, so I'll have to be very careful with that. Okay, it is only TXV now. First, I'm going to read and show you what is there in the data. It is, we'll see that. Let's see, separator is a tab. It is on Alexa TSV, separator is a tab. You can see this. Rating, date, variation, chaotic fabric, then verified reviews and the feedback. This is about Amazon Alexa feedback. This data is a benchmark data set already there. I've not created it. So normally we use this, and we have to understand the data, so we'll get information about the data, so we can see the shape information and the value counts, feedback value counts. You can see that there are 3,150 entries. The rating, date variation, verified reviews, feedback. Okay. Then detail is again, and memory usage we have seen ones and zeros. That is what we get. That is the feedback, either 1 or 0. That is 1 is fine and 0 is false, true and false. That is what we get. Okay. So we need the punctuations, and to remove that, few things. So let's see. We call that. So we have imported the string spaces already there, so I don't have to stop words and English already I imported, but I'm just putting it here just in case you run only one command. From here, then you'll be needing it. Now, punctuations, string dot punctuation, we're calling that, and we're just printing what all punctuations are there. So this will be used to remove the punctuations from the text. It is just displaying what is there stored in the punctuations. Now, this is a big command. We have to create the stop words. I told you how to write the functions. In Python, when you have to start a function, we say def, and then the name of the function, like this. This is spaCy tokenizer. So what we have done is we have loaded the English. Then this function, let me go down first. We have just called the functions. This is printing. Okay. We have defined the function sentence. Tokens, we have called parser.sentence. Then my tokens, we are just getting the tokens from there. You can have if like this. If word lemma not equal to pronoun, else word lower for word in my tokens. This is for words in my tokens. On the left hand side, you see word dot lower. If word lemma is not equal to pronoun, else word lower, you are storing that. So word you are getting here. So for words in my tokens, you store word if. There are two parts to this. One is this. So read it. This is again compounded thing. You are removing the stopper, and how we are doing it is for word in my tokens word. Okay. From this you get the word. Now this word goes to the right side, right form. Now if word not in stop words, this one. If word not in stop words and word not in punctuations. So what you do is you store it in my tokens. The other one is lemmatization, the other one, and this one is removing the stop words. So for words in my tokens, if word not in stop words and word not in punctuations, it is neither a stop word nor a punctuation, then it will be removed. Only words without punctuation and without stop word will be stored in my tokens. Okay. Removing stop words and punctuations. So lemmatization, you have here a word in my tokens. If word lemma not equal to prawn, else word dot lower, word lemma to lower strict, that is space. We are removing the space and converting into lowercase everything. And if word lemma not equal prawn, then else word lower for word in my tokens. This is how your lemmatization is done. You can have in one loop also. You can create one loop, and with if else you can do that. Okay, so you can for word in my tokens colon, then if you can put, you have to strip it, and then we can check it. Okay, so return, this function returns my tokens. That will be tokens, lemmatized tokens, and without stop words and punctuations will be returned from the to the function which is calling it. Then we have a class here, predictors, which uses the function transform. This is I have not taken the classes, but this is used. This is the keyword which is self. Everything is linked. It's difficult if you don't, if you miss out something and you do directly. But anyway, I'll be using the. I will be telling you about the classes and the functions, how we create the functions, so that you'll be able to understand. For now, just understand the thing what we are trying to do. We are passing the two variables here to a class. Self is for the current. So return, what we are doing is we are returning the clean text. Okay, for text in next, clean text, and clean text has to be a function. This is the function which it is calling this function. So transform calls clean function and returns the clean text. Then we have another function in the class that is fit. That is self. X self will always be the first thing in the function. X, Y is none, fit parameters, then return self. Then there is another function called get parameters self, and depth is equal to true and returns it. Return empty, nothing, it's not returning anything. Okay, so basic function to clean the text. So define clean text and you put in the text, then return the text. Strip is removing the spaces, leading spaces, and or the trailing spaces, and then converts into lower and returns. Now these are the function. Now here we is the code here. Back of words. Now this is counter vectorizer. Tokenizer is equal to spaCy tokenizer, which we already had, and ngrams is equal to number of frequency of the numbers. Ngram approach is a very common approach. Then vectorize it using TF-ID vectorizer. Tokenizer equal to spaCy tokenizer. Then comes your loop. Now for sklearn or model selection, import train test script. You have to from you have to call the your train test in the script, and you have to split the test data. So first of all, let me get X, that is verified reviews, which we had earlier. We have seen that from Amazon. That is DF Amazon. That is the data frame of the data set. Then Y labels are feedbacks. You can see that we are getting the feedbacks. So X and Y labels we have created. So when we split, so we give X and Y labels, and test size is equal to 0.3. Random seed we have not set. It's not always required, but it is always advisable. But that is case in case you want to have the same result every time. Okay, so you can do that. Now, logistic regression we are using. Logistic regression classifier. I'll be explaining also detail. Theoretical part will do that. So last time we called NB, my bias. This time we are calling logistic regression from the model. So to call a machine learning model, what we have to do is from sklearn.model, linear model, or whatever model we want to call. In this case, it is linear. So sklearn.model, linear model, import logistic regression. Logistic regression we have called, and then we have to create a classifier called logistic regression. We create a handle to compile actually. We have to compile to get the results. Now we are creating a pipe. So pipeline we are creating to clean, vectorize, and classify. So in this we have got three functions. One is predictors, one is bag of words vector, and the classify. You can see that it is there. Predictors we have called, okay, and then bag of word POW. POW also we have. Yeah, this is POW, and then what else we have called? There's one more. Yeah, classify. The classify is logistic regression. So these all we have called, put it into pipe so that they can perform one by one. Sequentially, first predictors will be performed. Predictor will be performed. That is cleaner, vectorizer, and classifier. So put that. Then model generation always pipe.fit. Now I'll be using pipe.fit, not the classifier, because we have already called the classifier. There you can see that classifier is in the pipeline. So you can call it directly, or you don't. You if you don't want, then one by one. Then pipe.fit. This is actually you're generating the model, compiling the model. We can say compiling the model or generating the model. This is applying your machine learning algorithm on the training set. So X train and Y train you fit. Then again we are importing matrices to find the this is for accuracy and all. Then prediction is again, now we have to use pipe to predict X text. So you can put into pipe, and then again you can find the prediction, and then we have just calculating the accuracy now. So regression accuracy, precision, and recall. So we have calculations for everything. You have to run it and see if it's running fine. So it is, you can see that the accuracy it has given 98%. Accuracy is 94, then precision recall again 95 and 98.87%, which is very, very good. Very close to your 100. So 94, 95, and 98.87 is what you get. Coding could look a little complicated, but you can always break it. This compounded loops you can always break. So I've applied LR on this, and we have broken it, and you see that, right? So I can break it. I'll show you how to break it also, but I'll have to tell you how we create the functions. This is just you just go through it. You don't have to worry about understanding, because I'll be taking it again, because I have to take the logistic regression. But before that, I'll have to take the functions, how we create the functions using the def parameters. So def we have to use, and then I have to use then tokenize. All we have to do one by one. Okay, so I'll be explaining that again, so you need not worry, but just go through it, because these codes could be a little complicated, but uh, you need cleaning actually in these cases, because if I open it up, then it will just create some chaos in the code. But the classes and functions I'll be taking now, so that you can understand what we are doing. So machine learning we have applied actually here, and let's see that it is working. Right. So this is fine. I have to take. That is what I was saying, that everything is so connected that I cannot take anything from between. But this is okay. Uh, this is just applying some tools, modules, reading the data. I have to upload the data also. Let me first Alexa TSV. Download that. Otherwise, I'll have to change. Okay. Now, let me save this notebook on GitHub. I have to share the link, although the link you have is okay. This works fine, but still I will share this. Thank you. And I have to put it on the group also. I'll be taking them one by one also, so don't have to worry about that. This is just an introduction of what happens or what you can do. So let me share it on the group also. Okay. I have to upload the data. Also, otherwise it is not going to help. So let me upload. It is Amazon Alexa that is already there. The data is there. So I've uploaded that. So let me have to commit the changes. And I'm sharing the base also. Okay. So you can see that the data is there now, and yeah, the code is also there. So you can use any thing sklearn, you can use scikit, you can use spaCy. spaCy actually is more accurate in terms of tokenization and all, gives you better results, but the choice always lies with the programmer, what the programmer wants to do. So what we are doing here is text analysis. This is important. So we have applied two machine learning algorithms here. One is naive Bayes and one is logistic regression, but we need to understand these languages too. So I'll be taking that, and with that I have to take the basics again to create the functions and the classes. Without functions and classes, everything is function based. In Python, to start a function, we use def command, def, name of the function and parameters if required, or we can have the empty functions also without any parameters. Okay, default parameters can be there. So just name of the function or the round bracket, have a function where you can do the process and then you can call the function by the name only. So I'll have to take that functions. It's very simple. So we'll be taking simple functions and the classes to understand how the class and how the function works, right? So that we can understand the code, and then I have to tell you about something about the compounded for also, because that will be used most of the time for a cleaner program. We normally use compounded for so that we don't use multiple lines and get increase the number of lines and all. So we would like to reduce, because here we can give in one line itself, everything in one line. If else also can be given, and the conditions for loop, the loop we normally use for only in Python. And, other loops are not normally not used, like with, we don't use it. Okay, so anyway, just stop the recording. I've shared it, but I'm not shared. Let's see.